Great. Actually, I've been enjoying this as an attendee, honestly. Enjoyed Raj's thorough presentation, really set up the sort of the objectives and the goals for using AI for testing operations, as well as some of the challenges, which was great. And then of course Alex and Andre did a great job on the securing the infrastructure and the AI operations. So great presentations. We'll try and build on those. So our focus today, so thank you everybody. I appreciate your time and attention. My name is Dave Dugal. I'm the founder and CEO of EnterpriseWeb. I'm going to be joined by my colleague Bill Malik, who's our chief system architect, and he's going to do a live demo if the gods will allow it, and the webinar gods will allow it. And so we're going to move quickly through some slides just to set up the context for what we're doing, and then we'll go to the demo, and then hopefully there'll be some Q&A for us and the others. So our focus today, oh, I'm sorry, can you go back one? I just need to set that up. No, back. There you go. So thanks. AI-powered TestOps. Our focus today will be on the automation aspects of actually managing test jobs. So, so we're now talking about sort of where the rubber hits the road and sort of applying AI and all the techniques that have been sort of discussed throughout today's workshop, and sort of applying them to actual day-to-day operations of a telco where they have to test a lot of X and Fs. This is getting, in multi-vendor, multi-cloud environments, this is becoming much more of an issue for them. And so optimizing the use of resources and doing testing efficiently is an increasingly big deal and challenge. So we're going to speak to that. We're doing this in collaboration with our partners AWS and Rebecca. And you'll see that in the slide. If you could push to the next one, please. Thanks, Tom. So sort of going back to sort of Raj's, I'm sorry, this shouldn't, are you doing this PowerPoint or the, yeah, okay. So EnterpriseWeb, quickly, history. We ran the first ETSI NFV proof of concept, and that's first ETSI Zero Touch Network Service Management proof of concept, won a series of TMF Catalyst Awards. EnterpriseWeb itself offers an AI-powered no-code platform that is agent-based, and Netwrx.ai is our telecom solution for intent-based end-to-end orchestration and autonomous networking. And you can see we won a host of awards, et cetera. There's actually links on those if you want the data. When you get the slides, you can click on the links and get additional information about those use cases. Next slide, please. Great. To one of Raj's points, what EnterpriseWeb does fundamentally as a no-code platform is we're sort of bridging both AI, and I mean, when I say AI, I mean hybrid AI, all forms of AI, generative AI, AIML, RL, as well as analytics and rules-based logic with structured knowledge. If you remember Raj's talk, he several times talked about the importance of labeled data and context relationships. He specifically used it in talking about the depth of the telecom domain and the complexity, and the fact that some things are standard, some things are vendor-specific, and some things are operator-specific. So modeling that domain is still important in 2025, regardless of what LLM you might use. And in fact, our approach to architecture is a little bit different. We flip the script. Instead of trying to hook on to an LLM and, just do whatever you can to try to improve its accuracy and eliminate hallucinations, and make the LLM the center of the architecture, which puts you in sort of this tightly coupled, this tight coupling problem, in the sense that it gets very expensive to keep up with these models, keep up with their own updates, as well as take on new models as they bring in substantial new capabilities and better accuracy. So we make the graph telecom ontology the center of the center of a telco architecture, AI architecture, as opposed to the AI. We use the graph as a source of domain knowledge. We have an out-of-the-box telecom ontology. It includes a harmonized, standards-based graph-connected model of 3GPP standards, ORAN standards, TMF open APIs, ETSI NFV, Tosca, IETF, etc. It has all of those out-of-the-box, ready-to-use model. Plus, it brings in your real-time operational context of your XNFs, your services that are deployed, your telemetry and state of those services. So we feel like putting that in the center provides a strong deterministic basis for your operations that supports reliable and available networks. And then we augment that with AI as opposed to making it AI first, which essentially means you're being led by probabilities, and being led by probabilities exclusively will cause you some problems. I think you're showing the PowerPoint, so if you can hit the next two automations. Thank you. So if you think of it like it's almost like the left side and the right side of your brain, right? You have one side of your brain that is rational and has models of the universe that help you navigate it, and it's somewhat deterministic. Things are accurate, explainable, repeatable. It's always up to date, right? Precise and trusted actions. And then you have the creative side of your brain that is pattern matching, right? It's based on unstructured data. It's probabilities. And those are very useful, right? Inferences for detection, prediction, analysis, summarization, and recommendations. You want to bring both together. Just like with the human brain, you don't really want to just have one side or the other. You want two. My point is that fuzzy probabilities, fuzzy inferences augment knowledge. They don't replace knowledge. So having a telecom ontology at the center of your architecture is going to vastly improve your it's going to eliminate hallucinations. It's going to optimize accuracy of inferences. It's going to give you a deterministic foundation for your automations. Next, please. And our approach here, too, because we're using the ontology to do a lot of the processing, and in using an ontology or using any kind of database is a lot faster, a lot more efficient than an LLM. And we're able to work with an LLM in a very efficient way as well, because we have so much rich context in the ontology that we can send, Raj was talking about 250,000 context windows, and it's not enough. 250,000 token context windows. All our demos are all online, mostly on YouTube. We're doing 2 to 3 tokens per interaction. And a multi-turn interaction might be 4 or 5 round trips with an LM. That might be 12 to 15 tokens total to get an optimized output from an LM that's hallucination-free. That's transformative. It's going to lower, it's much lower latency because you're not trying to shove hundreds of thousands of tokens per interaction at the LLM. It's going to be, you're not going to queue because you're not throwing that kind of token traffic through. Also, it's going to be much more energy efficient and resource efficient. So just wanted to set that up because it really addresses some of the challenges that Raj had mentioned. Next slide, please. Thank you, Tom. So if you can just push through a couple more automations, I think it's 2. Yeah, just keep on going, and I'll just read to it. One more. Perfect. So EnterpriseWeb is agent-based, and so is our Netwrx.ai solution is agent-based, ontology-driven. So the agents are using the ontology to interpret events, evaluate conditions, automate decisions, and optimize tasks in real time, in telco terms, near real time, and hundreds of milliseconds. And the agents can then use that as well as AI, so they can, in sub-second speed, they can evaluate across the RAN, the core, and the transport, down to the NIC, down through all the OpenAI interfaces, Open RAN interfaces, through all the standard interfaces, down to the infrastructure and the devices, the IPMI, etc. Sub-second. And the agents then can dynamically compose, configure tasks. They essentially receive an event, interpret the event, generate a remediation plan, and execute that remediation plan in a second or so. And so the agents are essentially composing tasks into complex workflows and calling external functions as necessary to fulfill requests and respond to events in real time. So you can call this next gen. It's really, we don't call it agentic because agentic seems lightweight to us. Agentic AI is agents that are tightly coupled to LLMs. This is agents that are bound to, that are working off the ontology. So we call it agent-based, ontology-driven. So next slide, please. And so in addition, we were talking about security, compliance, all those things like that. The agents are dynamically enforcing all policies on the fly at the same time. All your data security policies are applied sub-second. Data access, data governance, applied in those same pipelines. And so we're really, the whole point of EnterpriseWeb is enterprise-grade web scale. So we're really addressing sort of foundational concerns that are going to, I think, help telcos enable their ability to leverage AI efficiently. Next slide, please. So the whole point, I think there's a couple animations real quick, and the two more. Thank you. So I'm just trying to push them really quickly. So the whole point here is to use agents to improve developer experiences, accelerate service delivery, and automate service management. You're going to see when I hand this demo to Bill, he's going to be able to talk to the platform to design, deploy, and manage. In this case, it's going to be test jobs. And then the system is going to handle all the implementation details based on the architecture I just described. So next slide, please. And I apologize for speaking quickly. I know the video will be released by the good people at the IWBC as well as the slides, so you'll have an opportunity to revisit them. So, and the nice thing here too is forget graph rag, forget like trying to tune inferences. Everything that all the demos that you see for EnterpriseWeb, things that we've done with Dell, Intel, Red Hat, things that we've done with Microsoft across a wide variety of models, no training. We use. If you have a telecom ontology, you don't need to train the model. Or you can, and we could of course work with the domain trained model as well, or a small LLM as well. But because if your ontology is rich, it allows you to use that ontology against one-to-many LLMs. It allows you to adopt new LLMs quickly or to accept updates, because instead of investing discretely into each LLM, you're investing into your own domain model. And that domain model is an asset to you as a telco, and it's an asset across multiple LLMs in this rapidly evolving space. So we're going to help you to enable you to leverage AI very quickly without having to get a PhD in data science necessarily. So next slide, please, and we're into the use case. So now we're just applying this to TestOps, right? So there's a problem, right? There's a couple of automations here. So if you can just, yeah, that's it. Perfect. Thank you. So essentially, we're just applying that the agent-based, ontology-driven, AI-powered automation to testing. So we're going to enable network functions to be onboarded in a model-driven way. We're going to enable test jobs to be composed. We're going to enable resources to be discovered and recommended. We're going to enable things to be deployed, instantiated, and then managed zero-touched. We call this an intelligent meta scheduler in this use case because essentially we're able to abstract across environments. In this case, we're going to be working over AWS EC2 Spot instances, which provide a low-cost, on-demand, optimized resource spend. And I'm sorry, I think there's one more click here, one more automation. There we go. And working with our partners at Rebecca that have some testing for testing network functions. In this case, 5G network functions. So I'm going to hand it to my colleague Bill now, who's going to just show you the 2 steps of the demo, and then he's going to jump into the demo.
Yeah, great. Thank you, and great to be talking to everyone. Can you please advance the next slide? Thanks. So in the demo, what you're going to see me do is a very brief version of the sort of expanded story here, right? Which is basically to test something like Open5GS, which you're going to see in this example. I onboard it to the system, which I'll just talk to, and I'll double click into it, show you the details while the tests are running. But basically, we take what we're given by a vendor, zip files, what have you. You can see the details on the left. Our system will map it automatically to that graph and use it to execute tests. Once it's onboarded, right, and as many workflows as you want, add them all to your catalog, or sorry, workloads. You then just compose the test by talking to the system. I will literally just ask it to do an Open5GS test with some certain parameters. The system will pull the right tests out of the catalog that Rabaka supports, bind and compose that test together, create a plan for it, and execute. Can you jump to the next slide, please? And this is sort of what it looks like. And just to speak to it very quickly, that test job will enter our meta scheduler, which will determine exactly where it should place these workloads for optimal cost and all of those kinds of things, resource spend. Once it's actually confirmed by the user, it will manage the deployment of those services, initiate the tests and everything like that. It will do ongoing management of the actual service. So if one of these spot instances go away, it will heal the service and what have you, and continue the tests and basically make sure they get executed and then return the results. It's about as easy as you'd want it to be. So with that said, I'm going to show you. So let me share my screen here. Please let me know if you can see it.
Yeah, we got it. Yeah, it's good, Bill.
Perfect. All right. Thanks, everybody. So I'm going to log into EnterpriseWeb itself. And what I'm presented with, we're, in this case, configured to do the TestOps. So I'm presented with all the details that I really need as a testing engineer. A set of the tests that have already been run, a catalog of workloads that have already been onboarded. We'll double click on the Open5GS in a minute, and a set of tests that have been mapped from Rabaka. And it's very easy for us to add these through a model-driven process to the system. Take 10 minutes maybe to add a new workload into your system, and then it's ready for testing. So once that's all done, and I'm going to, again, just to be clear, I will go into some of the details while the tests are executing in a moment because we only have a bit of time. So I'm just going to show you what it takes to launch a new job in EnterpriseWeb. Create a new small test of Open5GS. So the system's able to go in and quite literally pick out the tests that might be relevant to that situation, sizes of it, what have you. And just like that, I can actually send an order to the system. That meta scheduler that Dave just mentioned actually did a whole bunch of analytics predictive against the data that came out of CloudWatch, AWS spot instances, whatever. But it identified basically that for me to be able to execute this test, my best based on resource families, the best regions happen to be all in the east right now. But again, this is real time based on data that's coming out of AWS. I can find out what the cost is going to be for me to execute these jobs, and what's most important is what the savings are of actually using these ephemeral instances. Since we can manage everything in real time, it's very convenient for us to use basically the cheapest resources available to manage these things wherever they happen to be, and effectively just get the job done. I can see what the estimates are for time that this is going to take to run and the likelihood they survive. All these things are being taken into account to basically give me the best possible plan here for testing. So I'm going to order that test. And you see it's right just like that. It's already started. It's now appearing inside my my dashboard here. I can see it's pending, and if I update, you'll see it's into the testing phase already. So I can start to drill into any of the details here, and I'll do this just really quickly. But we give this kind of full transparency of what's going on. So in that split second, it determined a plan, and I'll show you why that happened in a minute. About 2 minutes before this thing finishes testing, so we'll have a little bit of time to fill here. But basically, what's done already is determined where those workloads should be, deployed them, waited for our system under test to start, and then initiated a couple of tests. You can see a functional, a load test, etc. If I want to take a look at other tests that have already been completed, I get the sort of full visibility. And as a sort of test engineer, this is all I really care about. I ran my test at one point. I can see that, okay, these two tests that I picked out ran at a certain time. If I want to look at what the system actually did, so our side of it with the automation, you can see it did everything from analysis to gathering our tests themselves. One of them was identified as passing, one of them failed. And then it removed all my workloads and all that other good stuff. So it cleaned up the job afterwards. So, a quick process. It took basically as minimal time as possible, as minimal resource, as minimal costs. And in the end, what I care about in this case is, my low level detail, right? This one had some failures in it. So it's surfacing the failures to me. I can go into the detail that's coming back from Rabaka, but eventually my bottom line is for this particular test, if I'm an engineer, I can find out that the NAS sent a message in an unexpected format and what have you. It'll help me with any of my debug going forward, all that kind of good stuff. So it gives me the results that I want here. Very easy for me to set up and get. The sort of magic that makes this happen is that model that we have behind the scenes of all of the call them solution elements, so the tests and the workloads. So I'll just go quickly here and just show you. These are a couple of the workloads. If I zoom in on one of them, so the double click kind of thing, I can see for Open5GS what the system actually has behind the scenes, right? So it mapped it from a zip file that was full of images and other things that were related to this particular package. It went into the system and it did things like determined what the subtype might be. This is a 5G core, and you'll see all kinds of things here from the telecom domain. Identified the type, picked out app level models so that it would know how to test this, and really what's most important is pick the things out of the Roboca test catalog or any other test partner that we might be, in this case, onboarded or have onboarded to the system. Pick out of their catalog what the appropriate tests might be based on that intent you saw me have earlier. There's a whole bunch of other things. It map properties, it auto-filled interfaces, it even builds specifications for me. I can download the JSON and XML RDF of these things. But the two elements, just to show you, are we talk about it being part of a graph. Well, I can see the graph. So I can literally zoom in, and we don't have time to really get into it, but this is what makes our agents sort of able to do the kind of magic that they do, right? To automate, whether it's deployments and actual network services and manage them down the line, or in this case, manage tests of them. So this, we could go into a tremendous depth on that, but that graph is what makes it possible. And based on that graph, the system generated a test plan for me. And again, I don't have time to get into the detail here, but this is a process that the system built. It's just a state chart, which is a data flow process, basically a set of sequences, a sequence of stages and tasks that are based on the contents of the service topology. So it figures out what the details were that needed to be done to run this thing, even to the point where it's connected to Spot. So how to manage Spot instances, how to work with the particular testing tools that we might have, and all that kind of good stuff. And that's effectively what the system.
I just want to interrupt you quickly. Is a couple important things there. Is our platform generated that workflow deterministically. So it wasn't generated from GenAI, it was generated out of that ontology because we have much richer domain knowledge and an understanding of operational detail. And what it did, it took a template, a very high level template of what that test deployment might look like, and then it contextualized it for the specific details of that test, right? So it starts off with the ontology, takes a template, it's underspecified or generic template, and then the context of the specific test configures the specific workflow. But no manual intervention. You can go in there and tune it. You can refine it, extend it. Of course, you can go in and modify them and extend the ontology as well. But I just wanted to point that out.
Yep, and I think by now our actual test has been completed, right? So 100% completion in this case. I mean, if we go in, it's a little anticlimactic now because you saw it, but it will show us that end-to-end test that things have been completed to the point where termination actually happened. It removed all of our test elements, and we have those responses that we could drill into, right? So as opposed to the other one that had failures, and you can see the data goes down to whatever level you want, right? It's all aggregated here in real time, and of course we're logging it all. You can get these through APIs. And you can even drill into the KPIs that we generated. How much money did I save by running it in these Spot instances? Those kinds of things are available from our APIs. So that was my very quick version of our TestOps demo. Thank you.
Well, thanks, Graham and Tom. Hope we were within the time limit there.
Yeah. So do you have any closing comments, Dave, or should we just go to Q&A?
If there's any questions, I'd be happy to take them. So.
Excellent. Okay, so really appreciate that, guys. So if anybody has any questions or comments for any of the speakers today, then feel free. Andre is still on board, and Alex. So if anybody has any questions, feel free to raise them now. We've got a few minutes if we need to cover those. So I'm just going to throw one in here, Dave, in terms of, again, this is what I call one of my dumb questions. So I'm always allowed a dumb question. So how do you see what you're doing here, interfacing and adding to what we saw earlier from the guys at Keysight and also from Raj at AT&T? How does that dovetail in? What are the, help me out, because as I say, dumb question.
All right. Well, I hesitate to speak for others, but we've worked with Keysight on many award-winning projects before, so we have a good understanding of their offerings, though not all the details on some of these new ones. Keysight, of course, is popular amongst telcos, and we've integrated and worked with them previously. A lot of the use cases that they were talking about, we were almost talking at a different level than Andre and Alex's presentation, because they were really focused on first the infrastructure, which is going to be done regardless, and making sure that Gen AI infrastructure was sound and protected. As well as then they were sort of talking about securing and testing the AI operations, which of course could wrap what they could actually be testing what we're doing here, right? So this, you could actually say that, well, we were actually demonstrating an automation use case for real world telco TestOps, where they're testing network functions, so an operational concern. Of course, over the top of that, you could put secure, you'd want that all to be secure as well. So that, I think, flows naturally into what the folks at Keysight were saying. In addition, as to what Raj had just discussed, in I thought really good scope, actually, sort of covered the field, was, and I actually appreciated that he talked about sort of candidly about challenges. You have all there's things that you'd like to do. There's things that people are being told that they can do with Gen AI, and some of that's not necessarily true, or some of it's some of the logic is also being questioned too, right? It's like, gosh, you spend so much in training, tuning, and tokens just to try and get accuracy and minimize hallucinations. Can we sort of question some of that? Right? There are some people in the world that are saying, no, Gen AI, it's all about brute force. You need, the answer to everything is more GPUs. I just don't believe that. I have nothing against GPUs. I have nothing, we work across CPUs and GPUs. We've benchmarked extensively in the Intel labs. So everything, the kind of automation you've seen today, we've benchmarked with on Dell Edge servers and Dell data center servers. Working with Intel's, Xeon 4, Xeon 5, as well as their Flex 170, I believe it was, processor. And so we can dynamically schedule workloads across CPU and GPU. But to us, it's like at some point this becomes a practical concern for a telco operator is, hey, I really just want to leverage AI. I want to make my operations more responsive, more efficient, more reliable. Right? Those are the things that the telco business really wants, and they like to mitigate some of those concerns. So I think what we're doing is, in regards to those challenges that Raj pointed out, is we're presenting an architecture, an ontology-driven approach, not just GraphRag. I look at GraphRag as being like a glorified, super expensive document highlighter for an LLM. You can spend a lot of money building up all this like GraphRag infrastructure around an LLM, and all you get is a marginally improved accuracy, which will still be inconsistent. Nothing says that the accuracy will be consistently 90%. And even you have to take these 90% numbers with a grain of salt, because a lot of studies show that for complex queries, accuracy, and especially complex, like if you're doing a series of queries, so the more complexity and the more relationships across them, the accuracy goes down to like 35%. So you really have to think that through. So starting with an ontology that's deterministic and putting that over the top of one or many LLMs addresses many of the costs of keeping up with change, adopting LLMs, minimizing training, tuning, and tokens, lowering cost, resource cost, and energy, gaining energy efficiency. So, I think that with some of the initial sort of hype behind us on generative AI, though it does seem to be ceaseless. I think that people are now looking at the practical concerns is how do we move this into production and achieve real business objectives? Raj talked about, cost per inference, I think it was, or cost per token, and and he started talking about some of the, well, how do we measure this? How do we benchmark this for business outcomes for AT&T or for any other telecom at that matter? And I think that's where we're focused. I hope
Right.
that was responsive.
Yeah, thanks a lot, Dave.